So we're going to look at special triangles and trigonometry, which triangles really fall within your trigonometry. You've been given this question, and they're actually asking for an exact value. Okay. What that probably means is that if you plug these into your calculator, you're going to end up with some number with a bunch of decimals. And what means we're really going to end up writing an approximation, which is not what they want. They don't want an approximation. So our special triangles allow us to leave things in like a radical form. So that if we leave an answer in a radical form, that would be considered an exact value, probably some fractional value with radicals on it. We'll quickly put down our two special triangles because when they're asking for exact values, it's usually because they want us to refer to these two triangles here that happen to have some very specific ratios to them, okay? They're both right angle triangles, and they have some very particularly easy angles to work with in terms of the ratio, okay? Assuming that this is 1, these distances, they would call this root 2 as the hypotenuse. And assuming that this is 60 degrees, this is 30 degrees, they call this the 1, 2, and then root 3, okay? So there's like a 1, 1, 2 and a 1, 2, 3 triangle. What's really important is in order to use these triangles, you need to be able to work with similar triangles. So we can scale this to a smaller size, so this hypotenuse changes and so do these legs, or we can scale it to a much bigger size. Hypotenuse changes and so do the legs, but the angles will all stay the same. That's one of the special properties of a similar triangle. So if we go ahead and take a look at this, we have 2 times tan squared 30 degrees. This, I'm just going to put a note here. This is technically like this, 30, and then all of this is technically squared, okay? The reason we don't write it, it's very common to write something like this, is because 30 is the argument to the function tan. And this kind of looks like it's 30 squared tan, so we just don't tend to write it that way, and we just put the squared in front of tan so that's easier to read. But for all intents and purposes, we're squaring that entire function there with the argument 30. So it might actually be easier to start with sine 60. Sine 60 might be a little more familiar to us. We know from our trig ratios that sine of some angle, we'll call the angle theta, is equal to the opposite over the hypotenuse, okay? 60 I have, it's actually part of this special triangle here. So if I'm at 60 and I need the opposite side and I need the hypotenuse, that's exactly it. I'm going to set this up. It turns out that sine 60 degrees is equal to the exact value of the opposite, which is root 3 over 2. So in other words, my next line of the equation, jump all the way down here, we get 2 times tan squared 30 degrees times, and I'm actually going to write in my exact value. It is root 3 over 2. So we've replaced sine 60 with that exact value, okay? We're going to do the same thing with tan. Tan is referring to 30 degrees. Well, that happens to be right here. So this is our tan. And tan, we know, theta is the opposite over the adjacent. So if I refer to 30 as my angle, my opposite is 1, and my adjacent is root 3. So in other words, tan 30 is equal to 1 over root 3. So in other words, on my next line, I'm going to jump again. I get 2 times, and I'm going to replace tan 30 with this value here, 1 over root 3. 1 over root 3. Now, the one caveat is, remember this is squared. So I got to still keep that as squared. I actually haven't gone through the squaring process. I just figured out what tan 30 was equal to. But don't forget that this is also still multiplied by root 3 over 2. So now what I have is some algebra with radicals, okay? All my trig is essentially gone. I'm just working with some fractions and some radicals, which is something I can do. I just got to remember my multiplication of fractions. This is squared. This is the same as writing 1 over root 3 times 1 over root 3. You might have just brought the 2 into both of these to quickly do it. Either method is fine. And we have root 3 over 2. And we'll do these just one at a time to make sure we get the multiplication correct. I'm going to make 2 a fraction 2, just since we're into multiplying fractions. Let's do that. We'll carry out this one. We do the numerator by each other. I still got 1. Root 3 times root 3 is actually just the number 3. And then we have root 3 over 2. The next one I'm actually going to go 2 over 1 times 1 over 3. That one's really simple. 2 times 1, 1 times 3, I just get 2 over 3. And then finally I have root 3 over 2 for my multiplication of my fractions. On top, I can't simplify. Because if I simplify, I'm going to actually have to find what a root 3 is, which means I'm going to approximate. They want an exact value. So to write that as an exact value, we write 2, and then we just write root 3 beside it. My denominator, I can do 3 times 2, that's 6. And lo and behold, that's my answer to this question. When they want an exact value, well, I did more work than I thought. There we go. Find an exact value. The exact value of 2 times tan 30 squared times sine 60 is 2 root 3 all divided by 6.